Electronic configuration for Cambridge IGCSE. IGCSE requires you to represent electrons in shells and as written electron configurations. I've also thrown in a page of exam style problems. Electrons in an atom are placed in shells around the nucleus. The general principles are that the shells nearest the nucleus are of the lowest energy, and that electrons are placed in the lowest energy shells first. So, one example, hydrogen has one electron. We know that from the atomic number of 1. That, of course, is placed in the shell nearest the nucleus, the first shell. Now, each shell has a maximum number of electrons that can occupy that shell. The first shell has a maximum of 2 electrons, and you are expected to recall that. So if we look at hydrogen, we've got 1 electron, as we've seen previously. We'll put that into the first shell. Helium has got 2 electrons. Well, the first electron goes in the first shell, the lowest energy shell nearest the nucleus, and the second electron goes in the same shell. Lithium with 3 electrons, well, the first goes in the first shell, the second goes in the first shell, but now the first shell is full. It cannot take any more than 2 electrons, so we put the third electron into the second shell. So the second shell also has a maximum numbers of electrons. Of course, that is 8. So if we look at carbon, fluorine, and neon, we're going to draw electrons in shells for those 3 atoms. Well, carbon has 6 electrons, 2 in the first shell. Third, the fourth, the fifth, and the 6th are placed in the second shell because there is room for up to 8 electrons in that second shell. If we look at fluorine, we've got 9 electrons, 2 in the first shell. That's now full, so we move on to the second shell and we start placing electrons in there, and we have room for 7 electrons. So there's 2 and then 7, so that makes the 9. Pause the class. Can you draw electrons in shells for neon? Come back when you are ready to check. Okay, so neon, first and second go in the first shell. That's now full, so we now place in the second shell. That has capacity for 8 electrons, but neon is said to have a full outer shell. That is, it has 8 electrons in its outer shell. We can't place any more electrons in that outer shell. Just as with the second shell, the third shell also has a maximum of 8 electrons. So 2 in the first, 8 in the second, and a maximum of 8 in the third. So if we look at sodium, as an example, I've drawn out here, 2 in the first shell, 8 in the second shell makes 10. There's 1 left over. That goes into the third shell. Silicon's got 14 electrons. Argon's got 18 electrons. Do you like to stop the class and draw the electron shell diagrams for those 2 atoms? Come back to check when you are ready. Okay, so here is silicon. 2, 4, 6, 8, 10. And there are 4 left over that go into the third shell because there's a maximum of 8 in the third shell, so it can accommodate 4 without any problem. Argon, 18 electrons, 2 in the first, 8 in the second, and 8 in the third. So once again, we would say that argon has a full outer shell. That is, no more electrons can be placed in the third shell of argon. electron configurations can also be written. Written electron configurations present the electron arrangement in a number series. So we've met already on the previous slide silicon, which has an atomic number of 14, that is, it has 14 electrons. 2 were in the first shell, 8 were placed in the second, and 4 were placed in the third. So we would write 2, 8, 4. That's a written electron configuration. So neon, sodium, fluorine, magnesium, calcium, oxygen, and helium. Stop the class. Can you write electron configurations for those atoms? Come back to check when you are ready. Okay, so I hope you've done that. It's best to complete the tasks if you've any doubt in your own mind. 2, 8 for helium. 2 in the first, 8 in the second. It's got a full outer shell. 2, 8, 1 for sodium. 2, 7 for fluorine. These are atoms we've met as shell diagrams previously. But what about magnesium? 2, 8, 2. It's got 12 electrons, 2 in the first, 8 in the second. That's now full, so remainder 2 in the third shell. Calcium, 2, 8, 8, 2. I haven't mentioned that there are more than 3 shells. Well, yes, there are. There's technically an infinite number of shells. So 2, 8, 8. Third shell is full, so put the remainder electrons into the fourth shell. Oxygen, 2, 6. And helium, perhaps a bit off-putting, just 2. That's it. Some review problems. So typically you might be asked to complete shell diagrams and or write electron configurations for particular atoms. So here's 3 examples. Just to be clear about the Cambridge IGCSE, you are not expected to write or draw electron configurations for elements other than element 1 to 20, that is hydrogen to calcium. So you don't need to have any specific information about the fourth shell other than it can take at least 2 electrons, but that's more an A-level topic. So back to the task. Chlorine, beryllium, potassium. Can you complete the shell diagram and write electron configurations for each? Stop the class, come back to check your answers when you are ready. Okay, so chlorine, 2, 8, 7. Beryllium, only got 4, so 2 and 2. We write that's 2, 2. Now potassium, thrown this in for a particular reason, of course, because 2 in the first, 8 in the second, 8 in the third. Now that is now full, so the remainder electron is placed in the fourth shell, 2, 8, 8, 1. Okay, so firstly, well done for finishing. You need to do some practice. Find some questions in your textbook and then go on to past paper questions. If you're not aware of Maths and Physics Tutor website, that has unlimited numbers of questions and past papers. If you want some more related chemistry classes, look at the playlist or the links that are included in this video description. If you found this helpful, please recommend it to a friend. Subscribe for new classes and last-minute exam tips. Please like. Thank you very much.